Hi everybody, this is section 1.4, dealing with segments and their measures from our Math 211 geometry textbook. All right, so the first thing we're going to talk about today is another postulate. It's the ruler postulate. So anytime you have points on a line, you can also pair those points to numbers on a number line. And that number that corresponds to the point on the line is also called the coordinate of the point. So again, we can measure the distance between those 2 points. When we calculate distance, it's always going to be the absolute value of the coordinates. And this is simply because when we measure distance, we never have any negative numbers. So we always have to find the absolute value of the two numbers. Think of it like if you get up in the morning, never do you wake up in the morning and say, I'm going to walk -2 miles today. Either you walk or you don't. Even if you walk backwards, it's still not negative distance. You're still measuring distance. It's like my Fitbit in the morning says 0. If I don't go anywhere, it's always going to stay 0. It's never going to give me negative steps. So distance is always measured with absolute value. And to find the distance between 2 points, you're going to take the 2 points and subtract the values for them. So if you take a look here, we have points A and B right here, and we are measuring the distance between the two. And they've labeled bx2 and ax1. So the distance, they did x2 minus x1. You could do it the other way around. If you labeled a x2 and b x1, that's okay as well. As long as you find the distance between them and the absolute value, we'll make sure you always have that positive value. All right, so here they want us to find the distance between MP, or the distance between points M and point P. If you take a look, they kind of helped us out here. M and P are both on a number line. The number that corresponds to M is -11, and the number that corresponds to P is 5. So the way that we can find the distance is, again, we subtract the two values. So they started off, they did one problem where they did 5 minus -11, which gave us positive 16. Absolute value of that would be positive 16. But then also they did it the other way. They did -11 minus 5, which gave us -16. And when you find the absolute value, it gives you a positive 16. So I like that they show both ways. What I would like you to do now is pause the video for a second. And I want you to find the distance between, N, Q. All right, so hopefully you paused the video, you took a second, you found the distance between N and Q. First, we have to assign values. If I look on my number line, N on the number line is represented by -2, and Q on the number line is represented by 13. So when I find the distance between N and Q, so when I go to find the distance between N and Q, I am going to do the absolute value of the difference between the two. So I'm going to start with N, and I'll do -2 minus 13, which again, when we think subtracting with positives and negatives, we do keep, change, opposite. So really, I'm going to end up with -15. And the absolute value of that would be 15. So the distance between N and Q is 15 units. Okay, the next thing that we're going to discuss is the difference between congruent segments. We're going to talk about congruent segments versus equal lengths. When we're doing geometry and we're looking at things, sometimes they will tell you two segments are congruent. And sometimes they'll tell you that they're equal to each other. And they, while essentially mean the same thing, they have different They give us different information, and we have to be careful how we use each one. So for the first one, if two segments have the same length, they are congruent. So if they tell me, and again, the symbol that we use for congruent is right here. So it's the equal sign with the wave on top. If they tell me that they're congruent, that means those two segments have the exact same length. I don't necessarily know what the length is, but I know they're exactly the same. Now, if they're congruent, it also means they're equal. And if they're equal, they're congruent. But the difference between the two is, if I know that I have two segments that are exactly the same, but I don't know any measurements, I would call those segments congruent. But if I know a measurement related to both, then I would call them equal. And notice the difference when you write them. If they're congruent, you put the line segment above it. If they're equal, you don't put the line segment above the 2 points anymore. So for instance, if I were to have 2 points or 2 segments, so I'm going to make this segment, we'll call this AB, and let's make this CD. All right, if they're marked with the same number of tick marks, so here they each have 1, this means what I can gather from this picture and what I know from the information is that AB is congruent to CD, and I would write it just like that. But instead, if they gave me a picture and they made it like this, so here's AB again, and they told me that is 2 centimeters, and then they gave me CD, and they told me that was 2 centimeters. Then, because I know a measurement to each of those, I could say AB is equal to CD. That would be the best way to describe those two segments, because I know the measurements are equal. Congruent, it's almost like, and we'll talk about this more as the semester goes on, if they says they're congruent, it's like you're saying, you know, your office chair is exactly like the office chair next to yours. They're congruent, they're exactly the same. But if we're talking about equal, we are talking about the height of the office chair you're sitting in is 24 inches off the ground, and the height of the office chair next to yours is 24 inches off the ground. So again, with equals, you're talking about measurements. With congruent, it just means the two figures, we don't know any measurements necessarily, but we know that they are exactly the same. All right, so here we have a figure, a quadrilateral. It has 4 sides, and they have marked opposite sides congruent. So here I know AB is congruent to DC because they both have 1 tick mark. And I also know that AD is congruent to BC because each segment is marked with 2 tick marks. So to answer these questions, I want you to just pause the video for a second and try to answer them. They're pretty simple. I think you can get them. And then come back and we'll check them. All right, so you should have known BC is marked as 2 feet. They want us to find AD. Since I know BC and AD are congruent because they both have 2 tick marks, that means that AD is also 2 feet. Then for C, it says DC is 6 feet. Find AB. And again, DC and AB are congruent, so I know that is also 6 feet. Okay, so now what we have is we have some points on a number line, and they are asking us to tell them, is segment BG congruent to segment AC? So really they're asking, are the two congruent? So there's a couple of ways you can do this. Some people tend to just look at the number line and they can count in between. So from B to G, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. And then from AC, if we go, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this was 9 units, and this was also 9 units. So yes, the two are congruent. Another way you could have done it is just like we did before, we could find the coordinates for both BG and AC. So I know that B is -6 and G is 3. So then if I find the distance between BG, I would do -6 minus 3, which again, plus a negative, gives me the absolute value of -9, which gives me 9. And then do the same thing with A and C. So I know A is -10, C is -1. So when I find the distance between AC, I'll do -10 minus -1. Again, plus a positive right there. So that gives me a -9. And when we find the absolute value, it equals a +9. So two different ways to look at the problem. It's really up to you how you choose to do it, what you think is easier. All right, next we have our second postulate for this section, and it is the segment addition postulate. So add that to your postulate section. And really what the segment addition postulate is saying is if you have a point that is between two other points, then if you take the two smaller segments created, in this case, our large segment is AC, B is between A and C. So that means if I take AB, the length of AB, segment AB, plus the length of segment BC, and add them together, it will give me the length of the entire segment of AC. It's very simplistic. It's very common sense, but they're just, they've put names and words to it to help describe the segment addition postulate. All right, next we have a definition, and this definition is one that is very important in geometry, and we'll talk about it all the time. We will talk about the midpoint of various things, but right now we're talking about the midpoint of a segment. And the midpoint of a segment is a point that divides, or another keyword here is bisects, a segment into two congruent segments. If you have a midpoint, it's always going to divide your segment, or whatever it is into two congruent parts. Bisect means to cut into two equal parts. So two very important words here. If you take a look at this picture over here, we have line M and line segment AC. And these are true statements that we know from the picture. I know that B is the midpoint of AC. I know this because both AB and BC are marked with one tick mark. So that means I'm exactly the same, and B is between them. So it's the midpoint. I know that line M, because it goes through B, bisects segment AC. So it cuts it into two equal parts. Another way to say that would be line BD bisects segment AC. So they just name the lines two different ways. You could also look at it as ray DB bisects segment AC. We know because they are two congruent segments, we know that AB is congruent to BC. And then because they are congruent, we also know, even though we don't have any numbers assigned to them, that when we do have numbers assigned to them, these two segments will be equal in measure. And then another vocab term to kind of help you out is a line, a ray, a segment, or a plane that intersects a segment at its midpoint is always called the segment bisector. All right, so we're going to do a couple practice problems here. We're going to start off with the first one. We're going to use our segment addition postulate. And if we know that the entire length of MP is 47 units, they want us to be able to find MN and NP. Now, right now, I know MN is 5x plus 1. And I know that NP is 11x minus 2. So now remember, your segment addition postulate says, if I take my two parts, so if I take mn plus np, I should be able to get the length of the entire segment, which is mp. So I'm going to use the information I have to solve this problem. I know that mn is 5x plus 1, plus I know that np is 11x minus 2. And I know the whole segment, because they told me right here, is equal to 47. So now we have an algebraic equation to solve. Let's combine our like terms. So 5x and 11x will give me 16x. 1 minus 2 will give me a negative 1, and it equals 47. And then from there, I'll just solve my algebraic equation. I'll add 1 to both sides. So we get 16x equals 48. We'll divide both sides by 16. And we get x equals 3. So now I know what x is, but they want me to find mn and np. So even though I know what x is, I'm not quite done. I do have to go plug it in. So I'm going to do 5 times 3 plus 1, and that will give me 16 for mn. And then 11 times 3 minus 2. So I get 33 minus 2, so that will give me 31. And you can always check your answer too, because if I add 16 and 31, it should give me 47, and it does. So we did the math correct. All right, our second problem that we're going to try is we are finding the midpoint, or we're working with the midpoint here. So the midpoint of the segment AB is C. So we know, because if you have a midpoint, it divides it into two equal parts. So I know that AC is exactly the same as CB. So now they want me to find AC, CB, and AB. So to solve this, what I'm going to do is I'm going to take the two halves that I know are equal to each other and put them equal to each other in a problem. So I'm going to do 8x minus 6 and make it equal to 7x plus 3. Now we'll just solve the algebraic equation. So I'll subtract 7x from both sides. I get x minus 6 equals 3. Add 6 to both sides. And we get x equals 9, which is good, but we're not done yet. So we have to keep, go back and find, we want to find AC, CB, and then AB. So if I know x is 9, for AC, I can do 8 times 9 minus 6. I know that 8 times 9 is 72. And 72 minus 6 is going to give me 66. And then I can do the same thing for the other side. I can do 7 times 9 plus 3. 7 times 9 is 63. Plus 3 is going to give me 66. And you'll notice they're exactly the same, which is what they should be, because C is the midpoint, so we have two equal parts. The last thing they want is they want us to find the length of the entire segment, AB. So using our segment addition postulate, add 66 plus 66, and we should end up with 132 for AB. Because this is AC, this is CB, and that's AB. That is it for section 1-4. Have a great day.